This is my part 3 video on the Tower of Hanoi. In my part 1 video, I showed how to do the puzzle. In my part 2 video, I showed how to derive a simple formula. In this part 3 video, I'll show how to derive a more complicated formula. This looks complicated and busy, but it's actually really easy when I go through step by step. And a kid with just some high school math or middle school math could do this. Okay, so as I showed in my other videos, instead of using rings that you put on a peg, I went the cheap version and just used colored construction paper cards. So here's the number of cards and the number of rings in the puzzle: 0, 1, 2, 3, 4. Number of moves: 0, 1, 3, 7. I'm going to call this category with one card A, and then this is B, C, and D. The formula is 2n plus 1, so whatever you get for A, you just plug it in and you get B. So you take A, you double it, add 1, and you get B. You take B, you double it, and add 1, and you get C. So it looks like this: 2A plus 1 is B, 2B plus 1 is C, and on. You can watch my part 2 video where I showed how to derive this formula right here if you're so inclined. Over the years, I found that the most frustrating thing about deriving formulas is leaving everything in the right form until the exact right time. So if you go pulling terms out too soon or too late, then it just doesn't make sense. And you have to keep that right combination the entire way down through all the steps, because if you mess up and pull any terms out too soon or too late, then yeah, it just doesn't make sense. So yes, deriving formulas, it's kind of like solving a combination lock. If you know the combination, you just plug everything in, you turn the dial, and it's easy. But sometimes it's figuring out the right combination every single time. And so that's what takes a while sometimes. I just started with 2A plus 1 equals B, and I just kept doubling it. So A equals 1 actually, so I could just leave that as 2 plus 1. I initially left the A in there, but I just took it out because it equals 1. So 2 plus 1 equals B. I just bring this down, I double it, and I add 1. And I just keep repeating this pattern, so I'll end up with just having a 2 and a 2 and a 2. But I think what makes more sense in driving this is that I go ahead and distribute this all the way through. So I'll end up with 4 plus 2 plus 1 equals C. Then all I do is double this and add 1 to get D. So then now when I distribute this 2 through, I'll get 8, 4, 2, 1, and that'll equal D. Now the pattern emerges and it becomes more obvious. This is just 2 to the third plus 2 to the second plus 2 to the first. And anything to the 0 power is 1, so 2 to the 0. Now all I have to do is figure out what number D represents, which D represents 4 cards. So I just have to figure out how to turn 4 into the exponent, and that's just going to be 4 minus 1 gives you 3. So it's just 2 to the number of cards minus 1 plus 2 to the number of cards minus 2, and the exponent just goes on like that: cards minus 3, cards minus 4, until you get to the 2 to the 0 power. I kind of wish I could remember the first way I did this. I did this a long time ago and I filled up a whole whiteboard with equations, and somehow I left it in the form of 2n plus 1. But anyways, whatever it was, I'm glad I figured this way out here, because look how simple and clean this is. And this video just took a few minutes. I made this look easy, but it turns out if you try using this 2n plus 1 and leaving n in there, which n is the number of moves, it really didn't make sense. And if you try adding these numbers together up too early, then it won't make sense. And if you don't distribute that through, that 2 all the way through, you end up with a 2 and a 2 times 2 times 2, and you end up with this long line of 2's, and that didn't really make sense. So yeah, I got lucky on this and made it look easy, but the trick was like a combination lock. I'm just showing the combination on how I did it, so I made it look easy, but trying to find that combination sometimes can be tough.